Let me tell you about the night everything broke. New feature release, traffic increasing, teams on Slack celebrating, and suddenly pods stuck in pending stage. Services down, cluster refusing to schedule anything. No errors, no crashes, just pending. This actually happened in a real company I worked with, and today I am recreating the exact outage. Hit like right now because this episode is going to hurt. Welcome to episode 4 of the Kubernetes simulation series. In the last episodes, we fought crash loop back off. Services were not routing properly. And PVCs were stuck in pending stage. But this one is different. Today, the villain is not your YAML file, it's the node itself. This happened during a real product launch. Developers increased resource request just to be safe. They pushed CPU from 500M to 8 cores, followed by memory from 512MI to 10GI. They thought we have autoscaling, Kubernetes will figure it out. But the cluster didn't scale fast enough, and suddenly every new pod became unschedulable. That's the exact incident I'm going to recreate. Let's jump into the demo. I'm going to jump to my Visual Studio Code. In episode 4 folder, I'm going to jump back to my deployment.yaml file. Here, CPU is 20 and memory is 20 GB. Now we are going to run docker build command to build the Docker image, resource demo, latest, application folder I'm going to use. Press enter. Docker got built successfully. Now I'm going to run kubectl apply-f k8 deployment.yaml. Press enter. Then we say kubectl get pods. Press enter. If you see, the resource is in pending status. And there it is. Exactly what happened that night. Pods stuck in pending are the worst. Nothing crashes, nothing restarts, you get no logs, no stack trace, just this one cursed word pending. Now, here's what every DevOps engineer learns the hard way. You don't debug the pod, you debug the scheduler. We are going to run kubectl describe pod space and the pod name. Press enter. If you see the output of this message and scroll down, you see 0 of 1 nodes are available. Insufficient CPU, insufficient memory, no new claims to deallocate, preemption 0/1 nodes are available. Preemption is not helpful for scheduling, and that is exactly what was happening in production. The developers requested more CPU and memory than the nodes even had. Now let's try to look at our actual node. For that, I'm going to run kubectl get nodes, press enter. This is my actual node, Docker desktop. Now let's try to describe that particular node. kubectl describe node docker desktop. Press enter. If you look at the output of this node, I'm going to scroll down a bit and look at the capacity. It says 16 CPU and memory is also almost similar. But the pod requests 20 CPUs, 20 memory. This is the Kubernetes version of ordering 20 biryanis from a restaurant that only makes 16. I am going to update this with 200 M, followed by this would be 120 MI. Then we are going to update the limits. I would like to keep limit as 500 M here, and the memory would be 256 MI. Save this. Now, real quick, we are going to delete that deployment. Now let's try to delete the deployment. kubectl delete deployment resource demo. Press enter. Followed by, once again, we are going to apply that. kubectl apply -f kh deployment.yaml. Press enter. We recreated the deployment. Now let's try to run kubectl get pods and check if our pod is running. Press enter. You see the difference? It's running now. Previously we were seeing pending status. Now we see the running status. That's what the developers should have done. Let's look at the lessons from this particular episode. When a pod is stuck in pending stage, these are the real reasons. Node has insufficient CPU, followed by insufficient memory. Then resource request exceed cluster capacity. Autoscaler didn't add nodes, taints or tolerations mismatch. Node selector rules can't be satisfied. Node selector rules can't be satisfied. Wrong affinity / anti affinity rules. But the number one cause, over requested resources. Exactly what we just saw in our simulation. And that was episode 4 of Kubernetes simulation series. This is the first episode that mirrors a real production scale outage. If this helped you, comment episode 5 so I know you want more real Kubernetes disasters. Smash like button, hit subscribe, and I'll see you in episode 5 where the readiness probe fails and Kubernetes stops sending traffic to your application even though everything looks healthy. Thank you for watching and see you in the next video.